Hello and good morning, everyone. Thank you all for making time out and joining this webinar today. I'm Sharanya Palani and I'm an assistant professor of PC department at GRTIET. Today's webinar is on careers, options and opportunities for electronics engineering graduates. Sounds like a great one, right? I personally feel that career opportunities are the most challenging task to be obtained even though many of the students shine like a star at their academics. As we are fighting with this pandemic, career building will be definitely tough for the students who are doing their degree now. I certainly hope this session will definitely enlighten you to go ahead in pursuing your interest. Now we will turn over to the welcome address presented by Dr. P. SIVAKUMAR sir, HOD of ECE department. Please, sir.
Very good morning to all. It gives immense pleasure to welcome our chairman, managing director, group head HR and MR in their absence for one-day webinar. Next, it's my duty to welcome our principal sir, who is the backbone of this program. Then, I would like to welcome our today's chief guest, Mr. C.V. Ranjit, electrical architect, product designer, Philips India Private Limited, Pune, for the topic Career Options and Opportunities for Electronic Engineering Graduates, who has readily accepted our request and kind enough to conduct this program. Thank you for accepting our invitation, sir. Next, it's time to welcome our HODs and faculty members of our department, who is always behind every success of department activities. Then finally, I welcome the students of our department, that is today's audience of this program. Have a pleasant and knowledgeable day. Thank you.
Thank you for the warm welcome speech. Now it's the time for a special address from a beloved principal of GRTIET, Dr. S. Armugam sir. Please, sir.
Morning to all. Thank you so much. So I especially invite Mr. Ranjit sir, electric architect, product designer, Philips India Private Limited, Pune, which is kind-hearted. He had accepted our invitation. Actually, it was planned. So due to our internship program, this will be changed. We have requisition to Mr. Ranjit sir. They are accepted based upon our situation. So in this regard, Department of ECE organizing career options and opportunity for electronics engineering graduates. It's a wonderful title for the ECE department, particularly for the final year students and third year students. It is one of the most important topics for the present tense. Today we have a valuable chief guest, Mr. Ranjit sir. He will explain all the scenario about the electronics world and what are the expectations from the industry. Those things and all will be discussed during this session. I request all the students to make an active participation to grace the occasions. So finally, once again, on behalf of myself and the management, I'm conveying my sincere thanks to Mr. Ranjit sir for accepting our invitation to give a wide seminar. Department of ECE
And
HOD actors program or make this wonderful event for our students. So much. Have a pleasant day.
thank you for the addressing, sir. Now I'll invite Mrs. K. Periyaselvam, Assistant Professor of ECE Department, to introduce our speaker of the day. Please, ma'am.
Very good morning to all. It's a great honor for me to introduce our chief guest, Mr. Ranjit CV, Electrical Architect, Product Designer at Philips India Limited, He is having 19 years of in end-to-end electronic product, hardware design and development. He has completed his Master of Technology in Biomedical Engineering with distinction from Manipal Institute of Technology. He has designed and architected multiple media products for global markets, such as he has designed architected X-ray system, designed and architected medical X-ray detector, designed clinical chemistry analyzer, designed automated instrument cluster, designed X-ray image processor, and he has designed test jigs for consumer electronic product testing. He has attended various workshops and seminars in various institutions. He's a member board of studies and department advisory board in various engineering colleges. He acts as an examiner for BE and MTech projects. He has delivered lecture to over 9,000 students from over 130 engineering colleges and IEEE FB across India. He is having experience in conducting FBP lecture in various topics in electronics and biomedical engineering to engineering college professor. I'm sure we'll be interested by the webinar. Once again, I welcome you all for this function. Thank you.
Thank you, ma'am. Just a little housekeeping before we get started. For the students, if you have any queries during the presentation, please type them into the question box in your YouTube control panel. We will definitely bring them during the presentation, and we will also have time for the questions at the end. Now, without any further ado, we will present the session to the speaker of the day. Please, sir. Ranjit, sir. You can start the session now, sir.
Ranjit sir. Sir, shall we start, sir? Ranjit sir. Sir, mute பண்ணிருக்காரு அவரு. Mute பண்ணிருக்காரு sir.
Ranjit, sir, please unmute yourself, sir.
இல்லை நீங்கள் இப்போ பேசிட்டு இருந்தால் அதெல்லாம் பண்ணணும் சார். இஸ் ஆடிபிள் சார்? யூ கேன் ஸ்டார்ட் சார் நவ். சார் Sir, you can start, sir, now.
Hello. Yes, sir. Hello. Yes, sir. Hello. Yes, sir. This kind of
Ranjit, sir.
Sunil sir, what happened? Sornagopal sir? I can able to hear voice. Ranjit sir. Ranjit sir. Mm-hmm.
Sornagopal sir. Sornagopal sir. Hello.
Hello.
Can you hear my voice, sir? You please give the direction to the audience. Let them wait for another 5 minutes. You can give the direction to the audience, sir.
Audience, students. Okay. Students, wait for a few minutes. There is an interruption in the audio. You can wait for another 5 minutes. Yes, sir. No issue. No issue. No issue.
Yes, sir, joined. Ranjit sir joined.
Sir, Ranjit sir.
students को 5 minutes wait பண்ணனும்னு சொல்றாங்க.
அது சொல்லிருங்க சார். Stay in the audience wait பண்ணுங்க. Sir, serious.
Delay பண்ணி கேக்கும்.
Sir, we are not able to hear, sir.
Hello. Hi. Can you hear me?
Yes, sir. Yes, sir. Now it's okay, sir. You speak, sir.
Okay, fine. Okay.
Yeah, it's fine, sir. Now you can start. You can start, sir.
Yeah, I was not able to, hear you all this time actually. Sorry.
You can press, sir. Present, sir. Screen present.
Okay. Yeah.
Yeah.
Can you see my desktop now? PPT?
Yes, sir. Yes, sir. Yes, sir. You can able to see. But,
Yeah. Okay.
Hmm.
To PPT.
The PPT. Okay, sir.
So can I start now? Or
Yes, sir. Yes, sir. Yes, sir. You can start now, sir.
hello. Hi. Good morning to all. Thank you for joining this lecture. So today I'll be talking to you about the career options and opportunities after engineering in electronics. So I'll be covering various topics like career objective. Then I'll tell you about different options after engineering, which include higher studies. Okay, so I'll talk about that. Then I'll tell you a bit about the career in academic and research. Then I'll tell you about a different type of industries. Okay, and what type of work they do. Then I'll tell you about product development flow, where I'll explain you how a product is developed. Okay, and I'll tell you about a bit on the resume and interview preparation, and then I'll tell you about different type of jobs in industry. It's very important for you to know. Okay, and after that I'll tell you about the type of jobs in R&D. Okay, and also the skill set that you need to learn in various jobs in core electronics domain, like in software, like in embedded software to signal processing, to AML, communication software, etc. Then to hardware design, to Vlsi design. Okay, and after that I tell you about various components and tools used in industry. Okay, and then I'll tell you a bit on the next steps that you need to do, and also tell you a bit on various kind of trainings that you can do, both the training center courses and online courses, and then I'll tell you a bit of the subjects that you need to focus and the next steps actually. Okay, so if you have any questions during this session, you can type it in the chat box, and I will answer you at the end of this session. Okay, a bit on my experience. So I have over 19 years of experience in end-to-end product development, where I work on various kind of hardware design with the DSPs, FPGAs, and processors, etc. Okay, and I've also got a good exposure to the regulatory and reliability testing as well. So I have a dual master's degree, one in Vlsi Design and embedded system, and I've also done MTech in biomedical engineering, and my bachelor's degree is in electronics and communication engineering. So this is a bit on my my experience and qualification. So I've told you what I'll be talking today. Okay. So the first and foremost thing for you is to have a proper career planning. So this is very important because you are studying about 50 plus subjects in engineering. You are studying different subjects, okay, in electronics. You're studying, on communication, you're studying on, electromagnetics, you're studying on signal processing, embedded system, and Vlsi design, and software programming languages, etc. Okay. So what that means to you is that you have got broad varieties of opportunities. Okay. So you can work in various domains in electronics, and also you can work, in a computer science, also in a domain, also like in application development and various other things, actually network security and so on. Okay, so you have got too many opportunities. You can work in various domains in electronics, and you also work like a computer science or IT graduates do. Okay, but the main thing here is that since you're studying a lot of subjects, you need to choose and become specialist in that. That's very important actually, because you are not becoming masters in master in all the subjects that you are learning. Okay, but when you want to work in industry, especially, you need to choose a domain. Okay, so choosing a domain is selecting or defining your career objective, and then prepare actually. That's the most important thing you need to do. It's like if you want to go for a vacation, you have hundreds of places where you can go, but you need to first identify your destination. Then only you can. The same way in your career also, you need to identify the domain that you want to work, and you need to really learn on that actually. That's the most important thing, and ideally you should plan this when you are in third year, or at least in the beginning of final year. This is very important, not only for you to get a job, and also for you to work, and most importantly even for your interview, because the interviewer will ask you these questions about your objective, and even your technical interview many times will be focused on your objective. Suppose you say you are interested to work in signal processing. In that case, the interviewer will be asking a lot of questions on that, and if you are good in that, you can easily crack the technical interview. Okay. And also this will help you, to get a job and also to make you industry ready. And that's the biggest thing actually, because industry is also complaining about it. And you may have read about NASCOM reports and all that. Most of the engineers are not employable. The simple reason is that they don't know really what an industry needs, and also they don't focus on some of all the subjects. So they don't think about different subjects, and they won't become master in that actually. So this is a big challenge actually. Okay, so especially if you want to work in a product company or core company in electronics domain, it's very important. Not only in electronics or in any domain, you can say it's important for you to have a clear objective. Okay, so you need to really identify the domain that you want to work. Okay, so I'll tell you about that. First, you need to choose the domain based on your passion. This is very important. You should always choose something that you really like, because your career is very long, say 25, 30 years. It's very important. And the most important thing here is that once you identify the domain, you need to do a self-assessment and see whether you've got the skills and expertise to work in that particular domain. Okay, so this is very important actually. So, once you identified your domain, say for example, you identified your domain as a Vlsi Design, then you need to see whether you have got the right skills and knowledge to work in it. So during this session, I'll be talking to you about various skill set that you should have to work in various domains in electronics. Okay. So after that, you can do an assessment and see what all things you know and what are the gaps actually. And you have to focus on these gaps and make that as your strength. Okay. This is very important. Then only you will be industry ready. It's not just you pass the engineering, will not make you do, be industry. Suppose you say you want to work in Vlsi Design, so you should know what are the things that is needed, in Vlsi Design to work in industry. Because once you join the company, you need to work from day one. There won't be much technical trainings will be given to you. Okay, so you have to be very clear on this aspect. So identify the domain, then you need to see, whether you have got the right skills and knowledge there. And if you don't have them, then you need to learn that actually. And all of the things you have to do by the time you complete engineering or before you join any company. This is very, very important. And the third thing is that you need to choose the domain, or your objective based on the availability of job. That's again important because, if you are choosing a domain, you need to also see whether, that domain has got enough opportunities. Otherwise, it will be a bit difficult for you to get job. Okay, so it's very important. And the last thing is again very important because this is where many times students make a mistake actually. So generally, students, they have got a misunderstanding that, if you want to grow in your career, you need to, start in a big company, multinational company, or you need a very high salary. So this is what, students normally think. That's absolutely wrong, actually. What is more important is that in which domain you're going to work and what kind of projects you do and what kind of technology that you're going to use. This is the most important thing. And this is going to define your career. Okay, so please focus on this aspect. So many times students will say like, I don't want to start in a small company because they pay less and so on. Don't do that. You'll see the opportunities and the kind of technology that will be working that you're going to get a chance to work on. Actually, focus on these things because this is going to define your career. And
excuse me, sir.
Yeah. Yes. Yeah.
Can you go a little bit slower, sir?
Yeah. Sure. Okay. Okay. Yeah. Yeah. Okay. So you heard about the other points, right? What I've told already. Hello.
Yes, sir.
Oh, okay. Yeah.
We can able to hear, sir, but it's a little faster. Students feels it's like that.
Yeah. No problem, sir. Thanks for the feedback. So when you are choosing a career, you need to look at the long-term growth opportunities. So typically, what many times students feel is that to grow in your career, you need to start career in a big company or multinationals, or you need to have a very high salary. Okay, so these are absolutely wrong. Your career growth is purely depending on the technical knowledge and the technology that you're going to work. Okay, so this is going to define your career. So don't bother whether you're joining in a small company or big company. It doesn't matter for you. At the end, it's your technical knowledge, and the skill set that you're having that is going to define your career. So please focus on this thing. Sometimes students will join a big company on assumption that I can grow. If I work on anything, it's not like that. Okay. So have a clear objective to find a job in that particular domain. That's very important actually. Because then, especially that's where the core electronics domain will help you. There are a lot of companies, okay, small and big and all. So very good start your career. And once you gain few years of experience, you could easily move to a big company. So focus on this aspect. Don't focus on the salary that you're going to get as a fresher, and don't focus on the company size or reputation. That is not having anything to do with it. It's all about the technology that you're going to work. Because whichever company you're going to go, there are different kind of work. And if that work is not a career objective, then it won't help you at all. Right? So please focus on this thing. This is the most important thing, and this is step number 1. You need to have a clear career objective. Once you have identified your objective, you see whether you have got the knowledge and skills to work in the domain. This is very important. So I'll be telling you about that, and then once you assess it, you will get to know a lot of gap. Okay, so you need to learn that, and all those things you have to do by the time you complete engineering or before you join the company. Then only you'll be industry ready. Okay, so this in your mind. Okay, so these are the 2 important aspects, and try to get job in that particular domain. That is always helpful for you, and your career growth is purely depending on the technical knowledge that you're having, and also the project or the technology that you're going to work. Okay, so focus on these aspects. After your engineering, you have different options. You can go for higher studies. I'll tell you about that soon. Or you can, go for a job. You can work in industry, or you can work in academics or research. Okay, or you can start your own company. So these are the 3 options after engineering. So I'll tell you a bit on higher studies now. So you have 2 options after your engineering. One is you can go for MBA, but I'll tell you later where MBA is useful. Suppose if you want to work in R&D as a design engineer, etc., please don't do MBA as a fresher. It will not help you at all. Doing masters is highly beneficial if you want to work in R&D in a product company or core company, because you'll be specializing in certain domain. Okay, and you have a deeper knowledge. For example, you want to work in Vlsi Design or signal processing. Okay, in engineering, you are hardly studying 2 or 3 subjects in that. Okay, but whereas if you do ME, that will be studying at least 10 subjects. So you will have a deeper knowledge there, because you'll be going in deep actually, and that will help the industry. Okay, and that is also the reason why students with a master's degree will be paid high, and also will be recruited senior level actually compared to a BE graduate. Okay, so doing masters is highly beneficial. Okay, so think about that. And nowadays, you have a work learning program from Pilani also. So that's for the experienced engineers. Okay, so where while working you can also do that. Go about that. Having masters is highly beneficial if you want to work in R&D. Okay. So if you want to further, do research, you can go for PhD, and that will be useful, if you want to work in academics or research. Okay, and later you can even go for postdoctoral fellowship. It's a fellowship of say 1 to 3 years, offered at various universities in India and abroad. After the PhD. Okay, so this will be on the higher education. Now I'll focus more on the masters. Okay. So, initially I'll focus on higher education options in India. So there are a lot of courses, masters like ME or MTech, and then you have research degrees, master's degrees, okay, offered at IIT, ISC, and NITs, etc. Okay, so the difference between these 2 are research master's degree, you're focusing on more on research thesis, okay. And whereas in conventional ME or MTech, you will be studying a lot of theory subjects, and you will have practicals, etc., and dissertation, etc. Okay. So the most important thing here is that in choosing the specialization. As I told you in the beginning, as an electronics and communication engineer, you can do ME in various specialization in electronics, various specialization in computer science and IT. So that means you have got too many varieties, too many options, you can say, for specialization. But you need to choose your specialization based on your career objective. That is the reason I told you career objective is the most important thing, and it's the first step for anyone's career. You need to choose your specialization based on your career objective. For example, you want to work in signal processing, and if you do mean VLSI, it won't help you much really there. Because maybe you'll be studying 1 or 2 subjects there, and the focus here is totally different. Okay, it's for IC design. Of course, you can design an IC with some of the signal processing elements in that. That's different story. But the focus is totally different actually. So have a clear objective. Choose your specialization based on your career objective. That's the most important thing. Okay. So that's the reason why you need to have a clear career objective. Okay, so once you choose your specialization, please go through the syllabus also, because the course content and syllabus vary from university to university. Okay, so you need to know what you'll be learning. That's very important actually, because by seeing the name, you will not know what is the course content. For example, in Tamilnadu, you have an ME called Applied Electronics, ME Specialization called Applied Electronics. Many people don't know what is the content of that. Okay, but actually that's a really good course, for somebody who generally want to work in embedded system or in hardware design, etc. Okay, so you need to really go through this syllabus, then only you will get to know what you'll be learning actually. So that's very important aspect. Okay, so choosing this specialization is the most important thing. For that, you need to have a clear career objective. And if you want to go for masters, you need to prepare from third year, because you need to have good GATE score. It's very important for you to get admission in a good college with scholarship. Okay, so focus on that. You can also go for a higher education in abroad. You can do masters in America, and also you can do masters in various countries in Europe and Asia Pacific. I've considered these countries based on the availability for the job in core electronics. Okay, so as I told you before, you need to plan for your master education from third year, because you need to prepare for English exams like IELTS, TOEFL. This is mandatory. And for example, if you want to go to US, you also need to prepare for GRE. But these are the basic requirements. Okay. In addition to this, all these universities look at your technical skill set, the projects that you've done, and also the papers that you have published in reputable journals like IEEE. So this will play a major role for you to secure your admission, and most importantly, for you to get a scholarship. So please focus on these things. So just having a good score does not mean that actually, because you need to have these things also. So try to publish some papers, try to do many projects and so on. All these things will add value. Okay. And the second thing is choosing the specialization. So as I told you before, choose this specialization based on your career objective. Okay. Then only it will be helpful. And the third thing is the third thing is that you need to also study about the country. Okay, so what type of industries they have, and what are type of jobs are available, and what are the skill set that is required in that particular country. This is very important actually, because if you don't get jobs say after your masters, in that case you will have to return back to India, because your visa will get expired, and in that case you'll be equally paid like an ME. Okay, so MS from US, from India, will be equally paid actually as a fresher. So you have to be very clear in this aspect. Okay, study about the country, go through the skill set that is required there, and also so this is very important. So blindly don't join any country. We need to have a good homework, and then you choose the country. Okay, so keep this in mind. And study portal is the best site for higher education, where you can get a lot of information on various courses, scholarship, and all of the things. Okay, so FindMaster is another site, for example. Okay. Now I'll tell you a bit on career in academic and research. So if you're interested in teaching, you need to go for ME. So that's the minimum qualification you need to have to get job in college as assistant professor. Okay. And then nowadays there are a lot of colleges and universities or labs offering roles like research associate or project associate, etc. Okay. So these are also really good roles. So you could think about doing that after your engineering. It's even offered in IITs and NITs and AS, etc. So you could think about that. These positions are typically for a year or 2 or 3, etc. So you could think of joining that as well, and then after that you can move to academics or industry also. So so these are some of the options you could think that. Okay, so because the product company or core company, they want people with a good research knowledge and good basic knowledge, etc. So this kind of roles also will help you to get there. Okay. Now I'll tell you about different type of industry. So this is very important for you to know what each type of industry does. I'm sure that all of you are aware of IT service companies. So they are recruiting most number of students. Okay, and they do different kind of projects. Okay, they don't develop any product. They do projects for different customers, and all these companies also work in core electronics domain, like embedded systems, software, hardware, Vlsi design, signal processing or image processing, communication, etc. Okay, but the most important thing that you need to understand is that, see, they're hiring most number of students, so only very less percentage of the students will get a chance to work in core domain in this kind of projects. Okay, and that will be decided only after you join in the company. Okay, so what it means to you is that getting job is not a big thing. Getting the trial project is most important thing. So what these companies typically do is that once you join in the company, they will ask you to submit your resume, and based on the skill set in your resume, they will allocate you the projects, and that is going to define your career. As I told you in the beginning, so if you start working in say signal processing, then you'll be keeping on working in that particular domain. Whereas you start to work in application software, then coming back to signal processing is almost impossible. You can say. Okay, so that is the reason why you need to have a good skill set in your resume. So which I'll be talking actually. Okay, and and also it's very important for you to learn the things. Never stop learning once you have an offer. Okay, because that will be the biggest mistake you will be making. Getting job is not everything. Getting the project, that is going to define your career. It's applicable to any companies. Yeah? Whichever company you go, getting the right project, that is going to define your career. Okay, so please focus on this thing. Okay, keep on learning, have the right skill set, and I will tell you about the skill set that you need to learn to work in core electronics domain or in various kinds of specializations. Okay. And then your product companies where we design the product, we manufacture it, we sell it, and we support the customers, throughout, its usage actually. Then you have electronics manufacturing service companies. Okay, so these product companies outsource a lot of their, manufacturing duties like PCB assembly, system assembly. And even sometimes complete manufacturing. Probably you might have read recently that Apple has started manufacturing their phone in Chennai, for example, in phone. So these companies do complete manufacturing, part manufacturing, or even PCB assembly, etc. And also they do a lot of design services. Okay. And also, to test a product, after manufacturing a product, you need to do a lot of testing to test the product. They also develop the test tools actually. So that is also a kind of development. So that is also done by these companies. So there are a lot of companies in India. So companies like Flextronics or Simon has got
Excuse me, sir. Can you raise voice a little bit, sir?
Yeah. Yes, okay.
It's very low. That's why.
Yeah. Okay.
Thank you, sir.
Yeah. So so the companies like Flextronics and Salmin has got R&D center and even factory in Chennai, for example. So there are a lot of companies here, and this is again a growing domain because lot of companies are moving from different countries to India. So you've got a lot of opportunities because these companies manufacture it, and also they do design services for various customers. So then you've got a semiconductor company. So they design the ICs, they develop the softwares and algorithms that you can use in various applications. And also they develop the software development tools like Code Studio for the TI, DSPs or processors, or Silence here we would have for the FPGAs. Okay, so that is also done by these companies, and these companies also do the evaluation board design and the reference designs for various applications. So these are really nice companies to work, and majority of the semiconductor companies across the world has got R&D centers in India, and majority of these companies are in Bangalore, for example. Okay, then you've got the product certification companies. Okay, so if you look at your laptop charger or mobile phone charger, you see a lot of markings, right? CUL, etc. These markings are ensuring that these products are certified, and these certifications are finally ensuring that the product is meeting the regulatory requirement of a particular country and it's safe to use. This is very important. Without certification, you cannot sell a product even in India. Okay, so there are a lot of companies working in this domain, like ULTV, and so majority of them in Bangalore, and also IT companies like Wipro and HCI is also in this domain actually. So they also do the testing, and in central government we have a Samir in Chennai, for example, and also CET, ETDC, and so on. So there are a lot of companies in that. So this is a domain where you would think about it as a regulatory quality, or even testing engineers and so on. Okay, so I'll talk about that later. Then you have a government organization like ISRO, DRDO, Bharat Electronics Limited, and so on. So then, so to get job here, you need to have a high GREAT score, and they do a lot of research activities, research and development. Then you have other companies like railways, BSNL, etc. Okay, so then there they don't do any research; it's only service and maintenance. Okay, so of course they hire electronics engineers. So, but if your industry is to work in R&D, that's not the place for you to work, start your career. Okay, so you have to be very clear on this thing. So this is about different type of industries. So we have got a lot of companies in India, and I see like a lot of product companies, a lot of electronics manufacturing companies, and many more will be coming. Okay, and majority of them are in Chennai, you can say at this point, and a lot of semiconductor companies, etc. Okay. So now I'll tell you about product development flow. So this is the process that we follow to develop a product. It's not only for electronics product; it's actually for a mechanical or electrical, etc. Okay. So this is the process that we follow to develop a product. Okay, and all type of job in industries around this thing. Okay. So there are different roles. I mean, different activities here. To do that, you need different kind of engineers. Okay. So that's the reason why I'm explaining you this, because so that you will know actually and what are the different roles and why it is important, etc. Okay, so you will start a new product development. So at a product initiation phase, and this is the phase you decide to start a product development. Once decide to start your product development, you will do two things. So first you will do a customer survey and you will do a market research study. Okay. So the purpose of doing customer survey is to understand customer requirement. So finally, we are developing a product for the customers. So we need to know what the customer wants, what are things the customer wants. So, and we should ensure that we have this thing in our product. That's the first step. Okay. So if your product is not meeting customers' expectation, he will not buy the product, right? So that's very important. So we need to fulfill customer requirement. And the second thing is that we need to also do a market research study, because there are a lot of products in the market. Okay, I mean, the similar product, what you will be buying. So we need to understand about that product, its feature, specification, etc. This is very important, and these two activities are done by the sales and marketing engineers. Okay, so they will study about the competitive products, understand their features, requirements, I mean specification, etc. Okay, and also their issues and so on. And once you have all those things, then you will go through this activity, these things actually together with the customer expectation, and then you will define the specification of your product actually. Okay, so I mean we need to also know, suppose we are developing a mobile phone. Okay, so we know what a customer want, but at the same time we are supposed to know what the competitors are offering actually. Okay, so we have to always ensure that whatever product we are developing, it should be equal or better than the competitor's product. Otherwise nobody will buy, right? If you're going to buy a mobile phone, so you will compare the features, right? The same way we need to compare it actually before when we started developing product actually. So we need to know what are the features they are offering, what is the specification, and we should ensure that our specification is equal or better than that. Okay, so that's the main purpose of doing it here. And then you will define the specification of your product. Okay, so I mean during the concept definition, you will also do the feasibility study. So sometimes what happens is that you're developing something totally new, so we need to see technically whether it is possible for you to do it. Okay, so I mean that is first. And if it is technically possible, we have to also see the time and cost. So this is also an important factor. Sometimes you will have an idea. Of course, you can do that, but to do that, you may need a high-end processor. Okay, and that processor will add up the cost of your product actually. Okay, so we need to really see, whether it is feasible or technically, whether it is feasible, in terms of cost actually, that's very important. Okay, because if the cost is really going up, then customers may not buy the product, right? So we need to see that. And third is the development time. Sometimes, you may require, more development time actually. Okay, so then that also you need to consider actually. So all these things you have to consider. Then only, you will finalize actually what will be, your product specification and feature. Okay. So that's an important stage. Here we use a lot of LabVIEW and MATLAB and other things. Sorry, Thrilling and MATLAB and all those things actually in order to do that feasibility study. Okay, so it's important for you to know these things. Okay. So once you have defined the specification, after the stage, you will come to the design phase. So there's a pre-development phase, and in the design phase, the first and foremost thing for design phase, to define the architecture of the product. Okay, so we need to identify various building blocks. So in any product you develop, you have got various building blocks. For example, you take a mobile phone, you have got processor, display, camera, the power supply part, the battery, all the this, and also the mechanical enclosure. All these are different building blocks. You can say, or the user interface. These are the different building blocks. Okay, so that define the architecture of your mobile phone, for example. Okay, so once you when you're developing the architecture of your the system, you need to also consider the future requirement as well. For example, if you are choosing a processor, and if the processor is only supporting the current requirement, then in future, if you want to have more features, or need to have a larger memory interface, it will not support. Okay, so then in that case, what we will have to do is that you have to redesign everything, and that will add cost, and it will cost a lot of delay in the project. Okay, so that is the reason why when we are defining the architecture, we need to always look at the future requirements, and we have to see that whatever building blocks or the components that you're going to select will support that or not. That's very important aspect. Okay, so this is a very critical aspect you need to see. So your architecture should support current as well as future requirements, so that you can quickly launch new version or next generation of your product. Okay, and also you can reduce the development cost. That's very important. Okay, so once you define the architecture of the product, and next is actual development. In actual development, you will form separate teams like a software, hardware, and a mechanical team you'll be forming. Okay, and they will be doing different tasks in parallel. For example, the hardware engineers will be responsible for doing the circuit, selecting the components, and doing the circuit design. Then they will do the simulation, they will do the layout, and they will get the prototype done. Same way, mechanical engineers will be responsible for the mechanical enclosure design, heat sink design, and other thermal aspect design, etc. Okay. Same way, software engineers will be responsible for designing different kind of software, maybe the signal processing algorithms, so control interface software, or even the user interface, etc. Okay, and they will be doing it in parallel. And once then they will do the testing actually in the evaluation board, etc. initially. And once the prototype is there, they will do the testing. Okay, and during prototype testing, if they come across some issues, they will find the root cause, and they will, if that is calling for a redesign again, they will redesign. Okay, so then after that, it will go to the testing and validation phase. So this is a major phase. And in every company, there is a testing and verification team. So their job is to test the product. Okay, so test the product. They need to also develop some test protocols, test software, hardware, or automation set, etc. That is also needed there. Okay. So, and if during the testing, if they come across certain issues, then design engineers will look into the issues and they will fix it actually. Okay, and after that, the test. So initially, the testing is functional testing. So they will check whether it will work as per the requirement and so on. Okay, after that, you will be doing three kind of testing. One is reliability testing. You will go for the environmental testing, and finally you will go for the certification testing. Okay, so these are the three testing there. So the purpose of doing reliability testing is to ensure the product is reliable. So as you know, if the product is not reliable, okay, so that means if you have more failures, that has got a lot of impact, because it will affect the company's reputation, market share, and even some cases, legal issues could also have. For example, in a car, if the car met with an accident, and if the airbag is not deploying, okay, so the customer can go to court, and and the car manufacturer may have to take compensation, and in some cases even the government might also take legal action, and even they have to stop production and fix it actually. So this all will have a lot of impact actually on company's reputation and cost. So it's very important for us to do the reliability testing, in the design phase itself. Okay, so of course, you will consider various aspects, for reliability while you design it, but you need to also do the testing. Okay, so reliability testing is stress testing actually. So it's extensive stress testing where you will be stressing the system beyond its usage. Okay, so by doing that, we will get to know the problem. Okay, then we can find the root cause and we can fix it. Okay, so that the failure, the probability of failure occurring in the field can be reduced drastically. Okay, so we do here extended temperature test, humidity, and vibration test. So these are the common tests that we perform. Okay, so during all this testing, what we do observe is that we will monitor the performance of the system. Okay, we'll monitor various signals and see, okay, how the system work. Okay, for example, the vibration test is very important because every system you take, it's made up of different components, different PCBs, and also with which will be connected through a lot of cables. Okay, so typically what can happen is that due to vibration, sometime the components may come out, and it may pull the cables, or sometime it may come out and it will stop working, or sometime the cables may come out actually. Okay, so this can happen actually. Okay, and if that happens, your product will stop working. It's a failure, right? So we need to look. We will in the vibration test, we will simulate the vibration condition. We will vibrate it actually at a certain frequencies and so on actually, defined by various standards actually, depending on different type of industry. Okay. For example, in automotive industry, the vibration is very critical because your car is running on bad roads and so on, right? So depending on type of product. So it will be defined actually, and during this test, you will get to know some failures. You will get to know that some connectors are coming out and some parts are coming out, etc. Okay, so we need to fix that actually. Suppose if some connectors are coming out, then we may have to choose a cable with a good connectors actually, with a locking mechanism. Okay, so that it will withstand all the vibration. Okay, so this is one example, and if the components are coming out, then in that case, we may have to have a better mounting mechanism. Okay, so that it will not come out. Okay, so that by doing that you are improving your product actually a little bit. Okay, so next is humidity test, and humidity will cause condensation. So if your system is under your good environment, it will cause condensation, and this condensation will cause formation of water droplet, and this water droplet might enter into your system. Okay, and can cause short circuit actually. Okay, so that's a problem here actually. So by doing this humidity testing, you will get to know how good is your system enclosure, etc. So that this water droplet could not enter this system actually, and it can work at different humidity level. Okay. Next is temperature test. So this is a very important and most critical test you can say, because temperature has got a lot of role to play about the components behavior. So any system is made up of components. Okay, so as you all know actually, the resistor value will change with temperature. The error in ADC will also change with temperature, or the offset voltage in all will change with temperature, right? So what will happen is that if the temperature is changing, this will cause change in its output actually, and it will affect the operation, or your performance will get affected. For example, you don't compensate it, and you take your mobile phone, and if you take a photograph say at 10 degree, or you take a photograph at 50 degree, you won't get the same quality. If you don't do anything there. Okay, so so that is not acceptable. Ideally, when you say your phone will work from 10 to 50 degree, whatever performance is there, it should be of same quality actually. It should be consistent. Okay, so due to the temperature variation, the component output will change. Okay, and the performance will change, and even in some cases your system may even stop working. Okay, so this is one problem, and another is that the power dissipation of a component is also proportional to the ambient temperature. Okay, so if the temperature is high, the power dissipation will be more, and if you don't have a good heat sink design, or there is no proper cooling mechanism, that will also call for component the failure actually. Okay, so by doing this testing, you will get to know these two things. So one is component failure, and the other is variation in the signals. Okay, so then we need to fix it actually. These two things. So you will do extended test. So you may do the testing from -20 to 100 degree, for example, and you will do a rise and drop test. You will increase the temperature say from -20 to 100 degree in 10 degrees Celsius per minute, for example. So then you will monitor how the performance is varying, and then you will get to know till what temperature it works and what happens after that. Is there any component failure? And we need to analyze each of that. Okay, so for example, if there is a component failure, and you will also monitor the temperature of the component. So you will get to know that actually how much the temperature is going up. And you can go for reducing the power. You can reduce the power consumption by various methods. One is you can reduce it by reducing the clock frequency. Okay, so wherever it is possible, you can do that. Or or otherwise you can have a better cooling mechanism, and or in the heat sink actually. So that can also help you. So you can do that actually. That you will reduce the probability of failure actually. Okay, so that's one thing. And the functional data, as I told you, the signal output will change. So you can reduce that in two ways. You can do it in hardware or in software. In hardware, what you can do is that you can choose a component with lower tolerances. Okay, lower thermal drift, you can say. So if you have that, choose like that, then you can reduce the impact, but that will not eliminate completely. So you may also have some compensation circuit. Okay, but all these things will add a lot of cost to your product. The components with the lower tolerance will be expensive, and additional circuit will add up the cost. Okay, so your cost will go up. And it's not possible for all type of equipment, but in medical or in aerospace and all, it's possible. Okay. But typically in other way, what we do is that we do it in software where we monitor the internal temperature of the system and develop an algorithm to correct these errors. Okay. So if you look at op-amp data sheet, you will get to know how offset voltage is changing with respect to temperature. Okay. And with the input voltage, input temperature, you can correct this stress, but you can develop an algorithm where you take a temperature as an input, you can compensate actually, and this is how it is done in a product. So that is also the reason why software engineer working in product company should have good understanding on electronics, because you should know how the component behaves actually. Okay. Once the reliability test is done, you will go for environment testing where we do temperature, and humidity test. Okay, so here we will be checking the functionality. If you say your system will work from 10 to 40 degrees, you will test your system at 10 degree and 40 degree, and you will ensure that the performance is consistent. That's very important here. Okay, and then you will go for the certification testing. So as I told you, without certifications you cannot have a product in the market. So you will do the temperature test, you will do the regulatory test, safety test, and environment test again. So whatever you are claiming actually, your system will work at different temperature or humidity, that also has to be verified by the regulatory lab. So they will perform the test, and after that, they will do a safety testing. This is very important actually, because they have to ensure that the product is safe to use in normal condition, and in case of any failure, still it should be safe. Okay, it should not cause any hazards like shock, over temperature, or system catching fire, and so on. Okay, that's very important. Assume if your mobile phone, some short circuit happen, it should not cause any problem, like harm to you. Like mobile phone should not catch fire or it should not burst, for example. So that's what they will check there. So what they will do is that in normal condition, they will monitor the temperature or component and enclosures and those. So they will measure the current and so on actually. Okay, leakage current, etc. And after that, they will create a failure, like they will do short circuit at different point actually, and they will see what happens with that. Okay, so we have a lot of protection mechanisms like fuses. Okay, so if you do a short circuit and if you choose a correct fuse will blow, so it will not cause any hazard to the user, like the temperature will not go up and so on. Okay, but instead of say 10 ampere or 16 ampere fuse, you use a 50 ampere fuse, and what will happen is that in that case, fuse will not blow immediately. So by the time fuse blows, your system also will be too hot, and if somebody touches it, may get burned actually. Okay, so like that actually. So they will check these things actually during the testing actually. So the main goal of safety testing is to ensure that your system is designed with a lot of safety protective mechanisms actually, so that whatever happens to your system will fail, but it should not cause any hazard to the user. That's our main goal here. Okay. And after that, we will go for the regulatory testing. So this is the most complex one. Here we do electromagnetic interference and compatibility tests. Okay, so we have to ensure our system is meeting the regulatory requirement with a low rated and correct emission. Otherwise, it will affect the operation of other equipments. Okay, so there will be various standards defined, and it has to be within that. That's a very important aspect actually. And other is immunity testing. Yeah, so electromagnetic interference testing. So probably you might have noticed the older CRTVs. So whenever you turn on mixer grinder, you see lines, right? These are called electromagnetic interference. So that's not acceptable. So we need to have we need to do testing to find out the impact actually. So we need to have good shielding, filters, etc. Okay, on the power supply, so that you can filter out the noises, or shielding. So it will withstand all these noises actually. It is very important. Okay, so all those those things will be done in testing. Okay, so to see, once you complete the testing and if you pass the testing, you will get the test report. With that test report, you can go to regulatory labs, and from this with test report you can go to the regulatory authority in various countries, and they will give you the certification actually. Okay, so then you will go, after that you will go for the manufacturing. Okay, so why we need to wait for you to complete the regulatory testing is that many times during the testing you will have a lot of failures actually. Okay, so these failures will cause you for you to redesign PCBs, or maybe to improve your cable shielding, or maybe to improve your mechanical design with a good enclosure. I mean, maybe better enclosures, or then have a better some changes in the material, etc. Okay, so these are normal actually. That's the reason why we wait till we complete the testing. And after the testing is done, you will go for the manufacturing. So in manufacturing, you have different steps. So one is procurement, where procurement engineer will be responsible for purchasing the parts, and after that the part will be undergoing incoming quality checks that will be done by the quality team, and after that the product will be assembled, and and the product will be tested and it will be shipped to the customer. Okay, so there are different type of products. So one is like a portable device like mobile phone and all, which you can buy and use it. But if it is a larger equipment like CT scanner or MR scanner, you can't ship it single package. It will be shipped in different packages, and it will be installed with service engineer there. Okay, and after installation, it will be handed over to the customer. And if the customer is familiar with the system, he will use it directly. Okay, and if the customer is not familiar with the system, or then in that case we need to give a training, and that is done by the application engineers. Okay, they will visit the customer and give the training, then customer will use the system. Okay, after that, if customer face any issues, he will report issues to the service team, and then service engineer will visit the site and will look into these issues. Okay, and if they find any, then they will figure fix the issues. Okay, and after that they will inform issues with this the product company. Okay, they will report the issue details, and even there are if there are some failed part, they will send that. Okay, so once we get this part and failure details, we'll do root cause analysis. We will try to reproduce the issue in the R&D. Okay, because we need to analyze each and every failure. That's very important. So we will find the root cause. Okay, so there could be multiple reasons. Sometimes customer misuse. You may not use the same conditions that is given, voltages actually, or it could be component problems, or it could be some problem in the manufacturing, or even it could be a design problem. Okay, there could be multiple reasons. So it's very important for us to find the root cause. Then we need to assess the impact. We need to see whether the failure, the problem, whether the failure is very severe, or whether the failure frequency is high. These two things we need to do actually. That is very important actually. Okay. So we need to really identify actually, the severity and probability. Okay. And if it is very severe, and or if the probability of failure is high, we need to fix it immediately. So we have to stop, production and do a recall and do it. So it's common actually, okay, in automotive industries. And if the issue is not critical, or if it is not the probability is very less, you can do it later. Okay, so this is one of the reasons why we are going for a new version or facelift version of any product. And the second thing is that feature enhancement. We need to have better features over a period of time, again based on your competitors, okay, to have better market share. So adding a feature in a product is again a redesign. It can be software, mechanical, hardware change. Okay. And third thing is value engineering. Value engineering is, it's to, finally to reduce the cost of the product. Not the selling price, the cost to make a product, or to have a better features actually, okay, in product, okay, at the given price, so that to give a better value to the customer. So that is the main goal here. So in value engineering, what we do is that we do design optimization. As you all know, technology is advancing. A lot of advanced components are coming. For example, there are a lot of analog front-end ICs which has got amplifier features and ADCs inside. So you can replace all the discrete components with these kind of components. By doing that, you can reduce the number of components. By reducing the number of components, you can make a smaller PCB. That will be cost saving. By reducing the number of components, you can reduce also the component cost. Again, cost saving. And if you have a lesser number of components to assemble, your assembly cost also will go down. This is an example how it is done. Okay. So like that you can do in mechanical and so on. Okay. So then you will follow the complete thing. Yeah? So proceed. So I mean, a product development is a continuous activity. It's like a wheel actually. You have a concept, you develop a product, you sell it to customer. Based on the customer feedback, you will look into these issues, solve the problems, maybe add in features to reduce the cost, and keep on moving. Yeah? So this is how product is developed actually, and by involving in all those activities, you are also improving your knowledge. Okay, because when you design a product, you will design it based on certain things, but once it is in the market, you will have some certain new failures you might have not thought of actually. Okay. So all those things will help you to improve a better to improve the quality and reliability of the product, and also to improve your knowledge as an engineer. Okay, so that's very important. And all type of job industries around this. So I'll be talking about that now. That's the reason why I've told you. Okay, so these are different type of jobs in industry, and the most important thing here is that when you are choosing a type of job, okay, as I told you, this is step number 2. Step number 1, career objective. Okay, so where you need to decide, okay, in which domain you want to work, and then once you identify the domain, then you need to see which type of job you want to do. Suppose you will say you want to work in embedded software, so you have 3 roles there. You can work as a design engineer, you can work as a test engineer, or you can work in application engineering there. So these are the 3 roles. Okay, but you need to choose the role based on your one is based on your interest, but most important thing is that based on your capability. That is very important thing. So you will have some interest to work in R&D. Okay, but if you don't have the capability, then you will be failure there. So you have to clearly think about these aspects. Okay, so I mean, in our research or design and development, this is the product is actually designed, algorithms are developed, or softwares are developed. Okay, so to work in R&D, you need to have really good technical knowledge. Okay, getting job in R&D is difficult. Working in R&D is even more difficult because we have to work on different technologies in the given time. Okay, for example, if you are joining as embedded software engineer, in the first project you may be working on say ARM processor in C language. In next project, you'll be working in DSP. Okay, so to work all those things, you need to learn the thing. You need to work on different things. Okay, so you need to put a lot of effort. Okay, that is one part. And another part is that when you are designing something, okay, you'll be developing let's say for example processor or the software. Okay, but when you integrate in the system, you may face a lot of technical challenges. So that means you need to really spend a lot of time, and you need to have the courage, and you need to face these kinds of things. Okay, so that's very important actually. And the most important is that you should be ready to learn throughout your career. That's very important. R&D is continuous learning because technology is changing. Today you'll be working on one DSP from a Texas Instruments. Tomorrow maybe working in analog devices DSP. So the fundamentals remain same, but there may be additional peripherals, additional registers, and so on actually. So you need to learn that actually. Okay. So that's how it is. So R&D is a place for somebody who has got very good technical and basic knowledge, and who is hardworking, and who is ready to learn throughout your career. Okay, this is pure technical people. Okay, so that's the reason why it's always good to do masters or even PhD, to work in R&D. Okay. So, and you have to also understand actually, I mean, though it is a very difficult job, but it has got a lot of advantages. One is that if you join in R&D as a design and development engineer, later you can move to any other role. Okay, so that is possible. And also, typically, the salary is quite high actually. That's the biggest advantage. Okay, but if you join in any other role, you cannot go back to R&D at later point in time. So you have to be very clear. So, and testing engineers are responsible for testing the product or testing the IC. So they'll be developing the software. Product training actually. So if you buy an evaluation board or they say also Quixer in your college, some engineers will come there to give a training actually on how to use it, how to develop this software, and so on. Actually, they're called application engineers. They're not only for the colleges, they also with the industries. So whenever we buy a new tool, etc. Okay, so that's their role there. Then quality and regularity is an important role. I mean, as I told you, in whatever product you develop in whichever industry it is, you need to ensure that you follow certain quality guidelines and standards, and also we need to ensure that it meets a lot of regulatory requirements. Okay, so this role is very important, and that's the reason this role is also there in IT companies. All the IT companies and all the companies, you can say. So in quality, you have three roles, like a design quality engineer, product and supply quality engineer. So design quality engineer role is in R&D. Okay, so their job is to, when this job is there in all the IT companies actually. So their job is to ensure that design engineers or test engineers, so they follow proper quality guidelines based on some standards, and they will have proper documentation practices and so on. Okay, they will test as per the procedure, etc. Okay, so it's not much of a technical role there actually. Okay, then a product quality engineer. So as I told you, any product is made up of different components. Okay, so the product quality engineer's job is to ensure the quality of the product or the parts that is coming into the factory. Okay, suppose if the quality of the part is not good, the product quality is also not good, right? So they will do incoming quality check, they will verify the test reports, they may do additional testing sometime, and also they may they also visually inspect the parts actually, and then only the product be moved to assembly line, and there they will monitor the assembly, and also they will do extensive verification of the test report actually after the test is done. Okay, and finally they are ensuring the quality of the product going out of the factory. That is the main job actually. Then you have a supply quality engineer. So as I told you, the product is made up of different parts, and parts are coming from different suppliers. So the supply quality engineer will work with these suppliers to ensure the quality of the parts. Okay, they may ask them to do additional testing, and in case if some part failure happens actually in the field or in the factory, they will work with them to find the root cause and improve the quality of the part actually. Okay, so that's their job. Okay, so all of these roles are for electronics engineers. So then you have a regulatory. There are two roles there: regulatory and test engineer. So test engineer's job is to do EMI/MC and other testing, and regulatory engineer's job is to study the regulatory requirement and work with work with R&D engineers to ensure that they have taken care of this requirement while they design a product. That's very important. Suppose if you want to design a product for US market, so you need to have a low conducted and radiated emission. Okay, to achieve that, you may have to have additional filters and better treating, etc. So they will take care, ensure that these things are taken care by the design engineer so that the product can meet the regulatory requirement. Okay. So then you have manufacturing roles. So there are three roles here, and manufacturing is where the product data manufactured. It's a factory there. So you have got a manufacturing engineer, production engineer, and test engineer. So manufacturing engineer's job is to ensure, the factory has got right tools and setup to manufacture a product. Okay, so they ensure the readiness of the factory, because you need a lot of test equipment to manufacture a product. Sometimes you may need a spectrum analysis and various other things. So we'll ensure that factory has got these things. Okay, so then production engineer's job is to manage the daily production activities, ensure daily or weekly targets are met, and also to ensure the product is assembled as per the procedure given. And the test engineers are responsible in the product. Okay, so they will also develop the test software and tools and other things actually in EMS companies. Okay, then you have procurement engineer. So their job is to purchase parts. I mean, should the supplier on the pricing, ensure the part availability continuously. Okay. So they're also electronics engineers. Doing MBA is preferred here for this role, and service engineers for servicing the product, and technical writers are for preparing the data sheet and user manual of a product. So they're also electronics engineers with good writing skills. And sales and marketing engineers are responsible for selling and marketing a product, and also in the customer or market research study, etc. Okay, so doing MBA is preferred here. So for these two roles, MBA is preferred, and for the research or design and development role, ME or MTech is preferred. Okay, so choose the job wisely. This is the most important thing, and this is step number 2. Okay, so have a clear objective, choose it based on your capability and interest. Okay, and now I'll focus on research and development roles. Okay, so that is step number 3. So I'll tell you, don't know the required skills and the expectation from industry. So first and foremost thing for you is to have a good resume. So as I told you, before, based on the skill set in resume, you will get an interview call. Okay, so it's very important for you to have a good skill set. But most importantly, if you're already placed, the resume is even a more better role to get a good project actually, because whichever company you join, the first thing they will ask you is to submit your resume, and based on your resume, you will get a project actually. So it's very important for you to have a good skill set in resume based on your objective to get a good project. So focus on this thing. So that's what I'm repeatedly telling you. Never stop learning actually. Getting job is one part, but getting the project is most important thing. So please have a good skill set. Two type of interview. So one is technical and another is HR interview. So technical interview will evaluate technical knowledge. There will be multiple rounds of them. So the first round will focus on your projects and also the skill set you have written in resume. So please study your project thoroughly and your resume thoroughly. Whatever you written, you must know actually. So if you are using some evaluation boards in the project, you should also know what evaluation board architecture. We'll be asking you that as well. And then second onwards, we'll ask you a lot of questions, on your basics. Okay, so we'll ask you to draw different circuit diagrams, internal diagrams, and so on. Actually, so please focus on basics. It's very important. And then the typical success rate in a technical interview is, in our company is less than 20%. So you have to be very realistic on this thing, because you should have good technical knowledge. Then only you'll be able to clear. Okay. And second round is HR. So after your technical round, you'll go to HR. So HR will evaluate two things: your communication and presentation skills in English, and your behavioral skills. Both are equally important. You should be a team player. Okay, you should take ownership in completing the tasks, and you should be flexible in doing different tasks. This is very important actually. So HR will ask a lot of questions, group discussion, and they will find out actually. Okay, so you'll be rejected in HR round only due to two reasons. One is if your communication is not good, you will get rejected, and if you're not flexible, you will get rejected. So that is also one of the reasons why I've told you about the product development flow. I've told you different steps. So if you are applying as a design engineer, still sometimes you may have to work as a test engineer. That's important actually. Okay, so but the HR want to know whether you will be ready to work in that or not. That is a very important aspect actually. You need to always understand actually. So you should be flexible to do that. So you should never say like I will not do actually. So if you say that, you will be rejected, because we cannot hire a person who is not flexible, because sometimes there will be need actually. So you should be ready to work on that. Okay, so please focus on these things. And also after your interview, you need to ask some questions actually to the interviewers, because for that you need to study about the company and what kind of work they do. Okay, so these all things are important. Okay, so now I'll tell you about the R&D jobs. Okay, so this is step number 3. If you chosen that you are going to work in R&D, only 3 type of jobs in a product company at a high level. One is software engineer, one is hardware, and Vlsi design. So you have to decide this. So this is step number 3. Suppose you decided to work as a software engineer, then you can only work in software. Okay, you cannot go back to hardware or vice versa. So that's what you have. If you have a clear idea on this, you need to decide it. In advance section. Okay. So in software you have got different roles. You can move to any other roles within that based on your skill set actually, no problem. Somewhere here also, but move from software to hardware. Okay. So now I'll tell you about the skill set that you need to learn, and it must be in your resume. Okay, for you to get a job in these domains. Okay. So before I start, I'd like to tell you about embedded system. So embedded system is a combination of hardware and software. Say hardware, it's a combination of DSP, processor, and FPGA, because this is the biggest misunderstanding students are having. The other understanding is that embedded system is all about microprocessor. It's not true. No, it's about it's a combination. It's a combination of a DSP and FPGA. So you must know these 3. It's mandatory. That is also the reason why you need to do mini projects. Actually, you need to do mini project in all the 3. This is mandatory if you want to work in a product company. Okay, so now I'll tell you about the skill set that you need to have to work as an embedded software engineer. One is you need to know the architecture of all these things. Good understanding in electronics and its behavior properties actually, it's very important, because you need to develop a lot of algorithms. For that you need to know about the component, and they need to have good knowledge in DSP fundamentals like compression techniques, encryption, and all those things. It's mandatory. Without these things you can't develop any software, because you'll be using all that. Software is not just writing a code actually in a particular language. It's about developing a software for the complete system, because when you are acquiring data from a sensor, you have a lot of errors there. You need to correct that, right? So for that you need to know these things. So that's mandatory. And the language, if you know C or C++ is good, and the MATLAB is mandatory. You need to know one HDL, you need to know one RTOS, you need to know one DSP, one processor, and PG, and you should know all the communication protocols. It's mandatory. Okay, and device drivers, internal programming knowledge is also important. Okay, so you've got different roles. Okay, so to work in signal and image processing, you should have knowledge in DSP, image processing functions, and mathematics. This is very important. Also, you should know the architecture of DSP, processor, and APT. This is again mandatory to always understand. If it is image processing or signal processing, you have got acquisition phase and processing phase. Okay, even in acquisition, you do some initial processing. Okay, so you have a traffic that camera, right? So in that camera, you may use a DSP or FPGA where you'll be occurring the data, then you do some initial processing. Okay, and then finally in the PC you will do the processing, final processing. But you have to always understand, for high-end applications, these PCs won't be standard PCs. These PCs will be having separate cards which will be attached to your PCI Express and with the DSPs and FPGAs. Okay, so when you want to develop an algorithm, you need to know the architecture, otherwise you can't develop it. Okay, so that's the reason why you need to learn. And language, you need to have good knowledge in C or C++ and MATLAB. You need to know HTML, you need to know RTOS and DSP, processor and FPGAs and protocols, etc. Okay, so it's important. You've got different roles there. And to work in communication and networking software development, you need to have good knowledge in networking protocols, wireless technologies, radio protocols, communication techniques, and digital and wireless communication. This is very important. You should have a good knowledge in the architecture of DSP, processor, and FPGA, because whatever you do, finally you'll be implementing it in any of these platforms. So you must know that. Language, if you know C or C++ and MATLAB is important. You need to know HTML, you need to know ROS. Okay. To work in ANML, ANML it's a technology, so it's used everywhere. It's used in normal application development. It's there in your car, washing machine, camera, mobile phone, everywhere it is there. Okay, so to work in this domain, you should have good knowledge in ML, neural network and AI fundamentals. You should have good knowledge in DSP and image processing, because many times it is used in combination, and you should know the architecture of DSP processor FPGA. This is the most important thing if you want to work in a company, because these algorithms are implemented in these platforms. Okay, so you must know the platform, otherwise you won't be able to implement it. It's not just about developing an algorithm, it's about efficiently implementing there. Okay, you need to know C++ or MATLAB, and you need to know HTML, etc. Work in hardware design, you should have the knowledge in schematic rules from Cadence and Meta Graphics, because many students are learning Protus and the other things actually, other tools actually like Eagle or Protus and so on, but that is not enough. That is not industry tools. Okay, so you should learn the tools from Cadence and Meta Graphics. Okay, I'll tell you about that soon. You should have good knowledge in PCB design, layout guidelines, fundamentals. And you should have good knowledge in PCBs. I think you're learning in college, you should know HTML and C, because you will be developing some small programs to test your hardware, and you should know the architecture of DSP, processor, and FPGA, and various memories. Okay, and also knowledge in the components from resistor, capacitor to op amps to electromagnetic compatibility, etc. It's very important, and you should know communication protocols and so on. And there are a lot of jobs, different kind of hardware engineers, design engineer, electromagnetic engineer, compatibility engineer, a lot of roles there. Okay. And to work in Vlsi design, you should have a good knowledge in digital design, analog design, optical design. You should have a good knowledge, in signal integrity, semiconductor physics, and you should know HCL, that's mandatory. And if you want to be a test engineer, in addition to all these things, you should also have good programming skill set actually. Okay, and should have domain knowledge. Suppose if you're designing, codec IC for image actually, so you should have knowledge of the compression techniques and other things. Then you can develop an ASIC there, for example. Okay. There are different roles there, like design, layout, and tool development engineer. Companies like Cadence, Synopsys, and Meta Graphics has got R&D in India. Okay, so a lot of roles there. Okay, so these are the different type of jobs. So you need to decide which type of job you want to work and learn the skills accordingly. But by default, if you want to be a software or hardware engineer in a product company, you must know DSP, FPGA, and processor. So this is mandatory. Okay. And the embedded system is a combination of all. Okay. Now I'll quickly tell you about the components and tools used in the industry. So you need to work on this, and you should do a project. Just theoretical knowledge is not enough. You need to do some projects there. So ARM processor is the most popular processor. So you need to learn any one architecture of ARM processor. You've got different architectures for machine learning, neural network, cloud, and security, etc. Okay. So you can learn any one of the processor, architecture of the processor, that is good enough. But the most important thing you need to understand is that this is the most popular processor in industry. Okay, and also, as I told you before, to implement efficient code, actually, you need to know the hardware that you cannot implement a efficient code. Actually, so study the architecture And you have got processor controls from NXP, TI, microchip, and SD also. They have got different architectures, like from ARM to PIC and other things, but ARM is most popular one. PowerPC is also there. So if you're doing your engineering project, try to do, your final project on anything, on ARM processor like x86 or PowerPC. Try not to do PIC or other things actually, because those are hardly used in industry. Okay. And DSP have a TI and analog devices. TI has got a different type of DSP. So 6000 DSP is a higher performance DSP for communication and image processing application. There are two architectures. One is a DSP plus ARM, okay, single to multi-core, or single to multi-core pure DSP. Yeah? And the 55 is 11 DSP for basic signal processing applications. And you've got analog devices also like ADSP and Blackfin and Shark, etc. So Blackfin is one of the most popular automotive DSP. It's used in advanced navigation applications, etc. Okay, so learn any one of it, and you must do a project there. Okay, and FPGA have got Xilinx and Intel. So Xilinx 7 series and Ultra scale is high-end FPGAs, and the system on chip is there with FPGAs and ARM processors, even with the GPU, etc. Okay. So you can learn any one of it, or from Intel. Actually, Intel also got FPGA or system on chip with FPGA and ARM processor. So you can any one of it. Okay. So I'll tell you these are the components. I mean, whatever I've shown is the major the components from different one. I mean, type actually like FPGA or a DPA processor. So you need to learn this thing. So this is commonly used in industry. Any type of industry use it. Okay. So now I'll tell you based on IoT. So IoT, when you have a node, router, and cloud. Okay. So cloud is based on high-end process, it could be a DSP, FPGA process, or even GPU and so on. Okay, and the node is typically battery operated, so we need to have a power consumption. Okay, so actually IoT is not a separate domain; it's an application of embedded system, and it's a multidisciplinary domain where you need to have a different skill sets to work there. Okay, so better they know. So the node is typically battery operated. The power management circuit to monitor the battery. Then you'll have sensors from where you get the data. Then you will have signal conditioning circuit where you do some amplification, filtering, etc. And after that, you get the data to the processor where you do some additional filtering or correct errors here. Then finally, you do some compression and you transfer the data to the wireless module, and from there it will be transferred actually. Okay. And also this controller is very critical here because you need to manage overall power consumption and monitor operation and try to reduce the power consumption. Okay, so to work in IoT domain, you need to have a different skill set. You should have good knowledge in electronics, good knowledge in signal processing fundamentals, good knowledge in communication protocols. You need to know the architecture of the processor or controller, and finally the programming language. If you want to be a software engineer, just by knowing the programming language and the processor won't help you to get a job there, because you should know the other things. The fundamentals of signal processing and communication protocols all are important. Okay. So this is an example of machine learning used for object detection application. So this is implemented in an ARM processor. Okay. So again, FPGA is also used in AI and ML applications. So this is a performance comparison. I just want to make you aware that. So machine learning or ML, it's not about software. It's when it is going in a product, it's implemented in the hardware. Okay, DSP, FPGA, and processor. That's the reason I'm telling you need to know those things. Otherwise, you can't work on it. Okay. So MATLAB is mandatory if you want to be a software engineer. You must learn that because it is used everywhere. It's used for AI, signal processing, control systems, robotics, IoT, and everywhere. Okay, and it's also used for embedded and FPGA development also. And Simulink is gaining a lot of popularity. It is used for model-based design actually and simulation. So it's important for you to learn that. Okay. And lab is useful if you want to be in testing domain actually, and you need to learn that. And it's also used in FPGA development. Okay, in FPGA design, you have tools from Xilinx and Intel, and we have ModSim for simulation. Okay, and we have tools from Synopsys and Cadence. Okay, so you can learn that actually. And I will tell you about the tools that a hardware engineer need to learn. So this is not for software engineers. So if you want to work in hardware design, you need to learn the tool schematic capture tool from Cadence or Metagraphics. It's mandatory. So you can get the evaluation version from the website. Okay. So with that you can practice small circuits actually. That's good enough. And PSPAC, I think you're learning in college, and this is for layout simulation. Okay. Same way, Metagraphics also has got the tools. Anyone is good enough. And Hyperlinks is very popular layout simulation tools. Okay, so it's used for signal integrity, power integrity, and thermal simulation, etc. Okay, And and this is also signal dissemination tool. So you can learn either hyperlinks or this one. Okay. And if you want to work in communication hardware design or RF design, it's important for you also to learn tools from ANSYS, okay, or KeySat. Okay, so they have also got tool or from Catabota. So any one is okay. Okay, same way one schematic tool is okay. Okay, try to learn this thing. This will make you industry ready, yeah, because you know these are the tools used in industry. So you know it will help you there. Okay. Now I'll tell you about the things that you need to consider, you know, to enhance your career. One is that, as I told you before, you want to work in a product company, whether in software or hardware, you must learn DSP, Thousand APG, and you must do some projects there. That's compulsory. You can do small mini projects. That's good enough. Doing masters is highly beneficial if you want to work in R&D. You can do various courses. I'll tell you about that. And doing project in industry and internship is also helpful because you'll get a lot of chance to interact with industry people. That will help you. Paper publication is also important actually. And networking with the seniors or industry people are very important because you should know what is needed by industry, what are the things used there, and so on. That will help you. I'll tell you about courses that you can do quickly. So initially I will focus on the courses that you can do at training centers. Okay. I mean, a lot of institutes are offering program in embedded system. Okay, so it's good for software or hardware. So like CETA can offer the program in Chennai, or there are many institutes you can find it in various places. Okay, and IoT in CETA offer the program. They'll show IoT protocols and fundamentals, etc. Okay. And VLSI design is really a vast field, so you have to decide whether you have to work in IC design, layout, or FPGA design or verification, etc. Accordingly, you need to choose the course. Okay, so CETA course is typically for front-end design, and there are many institutes in Bangalore which you can find out actually for various courses. But choose it based on interest, because this is really vast that, right? And in DSP and image processing, a lot of institute offer this program in Bangalore. So currently even offer internship program. You can think about that. Okay, and AML also, you know, you can find a lot of institutes, but most of this institute focus on the fundamentals and programming generally. But if you want to work in a product company, this is not enough actually. Okay, so you should, you should know these things actually. Okay, the time, you should know embedded system actually. That's very important. Otherwise, you won't be able to work. Okay. And electronics product design for hardware design. So they will teach you hardware design techniques in Hyderabad or NLT in Calcutta for this program. And electromagnetic compatibility is again for hardware design. So somewhere in Chennai offer this program. Twice in a year, 3 days program. You could think about that. Okay. So the advantage of doing training center course is that you will get a chance to work on various platforms, various evaluation boards and tools. Okay, but every time it may not be possible because you may not have training centers near your college, or while doing engineering it may be difficult for you to do. Then in that case you could think about doing online courses, but you need to understand few things. The first and foremost thing is that just by doing a course for certification will not help you to get a job. Okay, so if you want to really have a value there, you can do some courses, but you must do mini projects. That is compulsory. Okay, especially if you want in a product company, you can do some courses, do some mini project initially, see your MATLAB, etc., and later you implement it in a DSP or FPGA or evaluation board in your college. That's very important. Okay, so that's the most important thing you must know. Just never do any course for certification because nobody give any value to that. Only your BE certification is having value. Okay, and it's important if you want to for you to learn ML, AI, and IoT. If you work as a software engineer, it's very important. Okay, so learn the course based on your career objective. Don't do any random courses because it will not add any value at all. Okay, decide your domain and learn accordingly. But if you want to work as a software engineer in a company, in a product company, it's must for you to learn ML and IoT because ML and AI is used everywhere, whether it is signal processing, image processing, communication, everywhere it is used. Okay. You can find a lot of courses, see the content and use it accordingly, but you must do some mini project and implement in a hardware platform. Okay, and you can also go to various sites like TA and NXP and all, for webinars or tutorials actually. So these are also really good actually. So you want to know about processors, you can go to this TA, NXP, ARM, or Analog Device, or Microchip, and ST, etc. Or even Intel. But if you want to know on DSP, you can go to TA and Analog Device, for example, like that. Okay. You'll find a lot of tutorials, recorded videos. These are also important, and webinars and so on. Try to attend that. Your knowledge will be improved. You can buy some of the validation boards from Microsoft for Raspberry is good board, or DSP over 5567 from TI, or a back from log devices. Okay, so these are useful for your learning or projects actually. Or you can use the board from your college also. You can buy FPGA board from Xilinx or Intel. And you need to focus a lot on electronic subjects even if you want to work as a software engineer. So these are the subjects you ideally need to focus. I just shown you few. Okay, you should have knowledge in electronics, then in a processor architecture, DSP, FPGA, all those things are mandatory. Okay, don't think that just in a programming language, it's not true. Okay, same way working in hardware or VLSI design, you have knowledge in electronics. Okay, that's mandatory, and electromagnetic system. And next step, as I told you need to have a clear career objective. Then accordingly you learn the skills, and that should be there in your scheme. That's very important. Okay. And second thing is, you have a good covering letter also. So your covering letter also should highlight, your brief skill set and experience, and then create a good LinkedIn profile. That is very important because a lot of hiring happens off campus, and then you can follow various companies, connect with HR. It will be helpful for you to try for job or even for internship, etc. And the most important thing is that you should try for job yourself, because anytime IT companies are coming for campus interview, but there are a lot of product companies that will go to selected colleges. So you Google it, you will find thousands of companies in various domains, and keep on applying yourself. But for that you should have good skill set. So I told you about this, what you should have. Okay, go to the Google it, you'll find the list of companies, then go through their website, find out the contact email, and you can apply there. Don't look at the job session only for the contact, because many times they will ask for the experienced people. They will say 4-year experience, etc. But that is so you don't focus on that. Actually, you can directly say it actually. Okay, because the companies will ask for experience. That does not mean that they will not hire you. They will hire you provided you have got good skill set. Okay. And then you will get the interview call, and if you have good at technical knowledge, you can clear the interview. Okay, so you need to try yourself. Don't rely on campus interview alone. That's not enough. Okay, so as I told you in the beginning, so your first job or the domain that you're going to work is going to define your career. Okay, and register in various job sites, and continuous learning is a must. Actually, never stop learning once you have enough. Keep up to date on technology, do various courses, and if you want to work in R&D as a design engineer, always good to do masters. Okay, so that will help you. Okay, so with this I've done the session, so I will summarize it one more time. Okay, so the first thing is that to have a clear career objective. Decide the career objective. Once you decide the career objective, do a self-assessment and see your gap, and make it and learn the gap actually. Okay, so that you'll be having good knowledge in that, and you'll be interested. Second is that decide which type of job you want to work. Okay, and if it's R&D, then choose whether you want to work in software, hardware, or Vlsi Design. Learn this accordingly. Okay, and you can also try other options actually, different type of jobs. Okay, so don't think that R&D is the only job. R&D is not the only job. Without only R&D, you cannot make a product. You need people from quality, manufacturing, testing, purchase. You need a lot of people, right? So choose it based on your industry capability. Okay, and don't think R&D is the only job. Okay, there are a lot of jobs, but you need to choose what is suiting to you based on your interest, and most importantly based on your capability. Okay, so with this I've done actually. So we have another 30 minutes or so. Questions you can type it, I will answer. Okay, what type of one question is what type of course is best preferable for software side? I'm again directly telling you which software. See, embedded software is also software. Signal processing is also software. Communication networking software is also software. You should be very specific, and you should choose the course according to that. Okay. So if you're asking me in terms of embedded software, by default you should know DSP, FPGA, and processor, and you need to know AI and ML fundamentals. These are the things. And language, if you know C or C++ is good enough. Okay. So you have to be very specific, because everything is different. I mean, as I told you in electronics, it's when you say software, it's all coming with hardware. So without hardware, you can't develop software. Simple. Okay. Language, you don't need to focus. You learn 1 or 2 languages. That is good enough for you. Okay. Hope that answers your question. Next question. Hello. Yeah, you can meet and ask me, or you can type out. So I will answer.
Students, you can unmute and ask the doubts to sir. Students, you can unmute yourself and you can ask the doubt.
Okay, sir. It looks like we have a question from Lokesh. As a fresher, can I get a job in machine learning and data science field? Is it, sir? Okay, okay.
பேசுங்க சார் சொல்லுங்க சார் ரஞ்சித் சார் Sir, we got one more question, sir.
Hello.
Yes, sir.
Ranjit sir has been muted.
Yes, sir.
No, unmute the presentation.
That one also you unmute.
நம்ம பண்ண முடியாது அவர் தான் பண்ணணும்
Sanjit sir.
Yes, sir.
ரஞ்சித் சார் ஃபோன் பண்ணுங்க
Augustine sir, you can make a call to Ranjit sir.
Okay, sir. You're working with us, not working with us. Check about that.
Sir, Rajit sir, can you able to hear us, sir? அவர் இந்த பக்கம் பேசுறாரு போல கேட்க மாட்டாங்க
Hello.
Augustine sir, you can make a call to sir. Now the problem is with Ranjit sir.
Not able to hear you, sir. Chatல
Sir, can everybody hear you, sir?
No, sir. No, sir. We are not able to hear you, sir. We are not able to hear you, sir.
Audience announce பண்ணிட்டேன். சொல்லிடுறேன், announce பண்ணிடுறேன். The questions will and the answers will be later this year. The questions and answers will be discussed later this year. Sir, audience announce.
Okay, guys, it looks like we are having some network issues. Sorry for the inconvenience. So all your questions and answers can be posted in the chat box. We will discuss it later.
Ranjit, sir, can you able to hear, sir? Message now, sir.
No, sir.
Okay, guys. So now I will welcome our beloved principal sir to say a few words about the program.
Once again, good morning to all. So it's a wonderful time for EC department. So Mr. Ranjit sir gave a wonderful presentation for our EC students. So particularly Mr. Senthilkumar sir spared his valuable time with his busy schedule also. He had accepted our invitation and today he had presented a vital role for the young engineers. Especially he has explained the various types of jobs available in universities like research and design development, testing areas, application engineers, quality and regulatory, manufacturing companies, supply chains, service-oriented job opportunities, technical writer, and sales and marketing. So these are the different types of jobs which are available after completion of the EC graduations. So with these able guidelines, particularly for the third year and the final year EC students, should get some overall idea of where we can place and where we can going to work for the industry. So in this regard, this useful seminar, Career Option and Opportunities for the Electronics Engineering Graduates, is a wonderful title chosen by our ECHU, Dr. SIVAKUMAR and his team members. So it gives a pleasant environment for the EC department students, particularly for the third year and final year students. I hope they will have they make this session as one of the important, useful session for their career. So some of the students, they may raise some valuable questions to the Mr. Ranjit sir. So I think most of the questions he was answered, and few more questions also the students are requested to post in the through chat box. Based upon that, sir will reply all your answers. So in this regard, once again, it's my sincere thanks to Mr. Ranjit sir and the organizing committee for arranging this type of wonderful webinar for young, dynamic EC students. Thank you so much. Thank you, please.
Hello, sir. Am I audible now?
Yes, sir, you're audible now.
Yeah, actually, sorry, there was some issues actually, yeah. The students
problem.
asked two questions actually. So the first one, one student asked about the software courses actually. So I mean, so the student has to first decide actually, which kind of software. When you say software, it's very generic term actually. It could be, application software, it could be embedded software, signal processing, or communication. So students need to decide which domain exactly they want to go, and the course will be based on that actually. Okay, so that's the most important thing that they need to consider. And the second question is about machine learning and data science. Again, students need to see in which type of industry you want to work in machine learning actually. Suppose if you want to work in a product company, you should learn about, by default you should know about the embedded system and the processors, DSPs and FPGAs. Okay. So accordingly, they need to decide the course. Suppose if you want to work only in application software, then you need to learn some languages and ML fundamentals actually. Okay, so that's how they have to decide. So they need a very clear objective. Okay, so not just software. Software means whether it has to be an embedded software, signal processing. Accordingly, they should decide. Learn actually, because the term is very vast actually. Right? Okay. Any more questions? Sorry, actually, not some issue with the audio. Okay. Any more questions? You can type it in the chat box or you can unmute and ask me.
It looks like we are not having any more questions, sir. Thank you for your valuable and knowledgeable session we had today. I hope that our students would have definitely gained some vision that how they can move ahead with the career options. Now, I would like to invite Ms. U. Sandhya, Assistant Professor of EC Department, to deliver vote of thanks. Please, ma'am.
Yes, ma'am. Good afternoon to all. As all good things come to an end, so is this webinar. I deem it as an honor to propose the vote of thanks to all who have helped us in making this webinar such a resounding success. I'd like to thank our honorable speaker, Mr. Ranjit, for making an excellent presentation and making this webinar interesting and meaningful. I'd like to express our profound gratitude to our beloved Chairman Sir, Managing Director and Group Head HR, Dr. Syed Arifullah Sir, for organizing this event. I'd like to express a profound gratitude to our principal, Dr. S. Armugham Sir, for his support and guidance for organizing such an event. I could also like to thank our beloved HOD Sir, Dr. P. SIVAKUMAR, for his moral support and guidance. I'd like to thank the coordinators of the event for making this seminar a grand success. I am happy to express vote of thanks to our staff members who have made this webinar a grand success. I thank all the students who have participated overwhelmingly and making the event success. Thank you so much for your cooperation. Once again, I thank all for your cordial relationship. Thank you.
Thank you, and wish you all good luck. Yeah, thank you. Bye. Thank you.
Thank you so much, sir. We had a great session.